Briefly, a few facts about fallout. To begin with, it may be surprising to know that radiation is something we live with every day. It has always been with us. Our own sun, like each of our millions of stars, is a raging nuclear furnace that shoots out showers of tiny particles along with invisible rays that we call radiation. In an average lifetime, a person might expect to accumulate about 10 Roentgens, not enough to affect his health. We don't worry about these small amounts of natural background radiation. But to safely handle larger amounts, we must keep our distance and shield ourselves. For as the amounts increase, so do the dangers. The amount of energy generated by a nuclear explosion is enormous. Near the crater area, there is almost total destruction from blast and heat. And now large amounts of pulverized debris and molten earth are pulled up into the mushroom cloud. The radioactive atoms produced in the explosion join with the particles of earth and debris. The mushroom-shaped cloud forms and climbs higher. It now contains billions of highly radioactive particles that we call fallout. The winds of the upper altitudes blow on the cloud, sending it in one or more directions. Some of the lighter particles may remain suspended in the atmosphere for days and travel thousands of miles before landing. But the heaviest particles drop to the ground within 24 hours. These are the most hazardous because they emit the largest amount of nuclear radiation. 100 miles from the explosion, they are about the size of table salt or fine sand. Within an hour, after a massive enemy attack, fallout would begin to be a serious problem in the vicinity of any nuclear ground burst. 7 hours later, the threatened areas cover more and more of the country as prevailing winds expand the fallout in downwind patterns. 24 hours, 48 hours, without shelter, millions would face death. Many people have difficulty understanding how silent, invisible rays, which cannot even be felt, could be so damaging. Our bodies are made up of millions of cells. They're the building blocks of our blood and tissues. When radiation penetrates the body, the cells are injured. Most of them can repair themselves if the total dose over a period of time is not too high. But if radiation continues, the cells will be destroyed beyond repair. We measure radiation in Roentgens. If people received more than 200 Roentgens within a few days, many would be sick, and some might require medical care. 300 Roentgens could cause severe radiation sickness, or possibly death. And as we go beyond 300, the danger increases rapidly. But we are not without personal weapons of defense. One is distance. The greater our distance from the fallout particles, the less radiation we receive. Radiation from particles 50 feet away, for instance, would not affect us as much as from particles a few feet away. You would receive less radiation in the middle of a tall building than on the top or bottom floors, because there would be more distance and partitions between you and the source of the radiation, the fallout particles covering the roof and the ground around the building. Only an insignificant amount would get inside. And along with distance, we have the most important defense: mass. Any material with enough weight will keep the penetrating rays from hurting us. Concrete, steel, and heavy construction materials provide good shielding from fallout radiation. And so would 2 feet of earth. And the greater the weight of the material between us and the fallout, the safer we would be. Taking a house as an example, it offers a small amount of mass and distance from radiation, but not enough protection in an area of heavy fallout. The fallout shelter is the best defense, whether in the basement of a single-family home or a large community shelter in, say, an apartment building. It offers the kind of protection from radiation you probably would need in case of nuclear attack. And along with mass and distance, we have a third invaluable ally, time. For deadly as radiation is, it has a fortunate weakness, a rapid rate of decay. Suppose a nuclear explosion takes place at 12 noon. By 1 o'clock, let's assume all the fallout is down. Then the total residual radiation would be at a high level. By 7 o'clock, it's down to 1/10. In 2 days, though still dangerous, it's only 1/100th. But in 2 weeks, it's only 1/1000th. So we would not have to take maximum precautions indefinitely. We need food and water to survive. But if fallout settles on your food, the food itself isn't harmed or made radioactive, since radiation only damages living tissue. You simply remove the fallout particles using everyday methods of food preparation: peeling, wiping, or washing. Fallout swallowed accidentally with food or in drinking water would do you no immediate harm. But for long-term safety, it's best to filter the fallout particles out. Actually, the hazard from contaminated food and water is very small compared with that from external gamma radiation. And hungry or thirsty people or animals should not be denied food and water because of possible contamination. If we remember these facts, if we act on them intelligently, we can increase our chances of surviving nuclear attack. And the key to survival is adequate shelter. That's why the federal government has a nationwide shelter program. The goal is adequate fallout shelter space for every man, woman, and child. And this goal can be reached. For with knowledge of radiation, we can face the facts about fallout and take action to protect ourselves against this hazard of the nuclear age.